Let's think about something for a second. Have you ever considered mathematics as its own language? I mean, it really is. It's got its own alphabet, its own grammar, and once you get the basics down, you can start to read these incredible stories that are written in it, stories about everything from physics to computer science. So today, we're going to learn the two most fundamental words in that entire language. So, what is the alphabet of the universe? It's a massive question, right? And you might be surprised by just how simple the answer is. It's not letters, and it's not even numbers. Not in the way we usually think about them. It's something much, much more fundamental. And there you have it, sets and functions. These two concepts, according to the classic text, Elementary Classical Analysis, are the absolute bedrock of modern mathematics. Everything else, it's all built right on top of them. So let's call this the alphabet of math. And here's why it's so important. If you want to understand the complex ideas buzzing around in modern science and logic, you have to get a firm handle on these two concepts. They aren't optional. They're the non-negotiable prerequisites for describing our world with any real precision. First up, let's talk about the nouns of mathematics. You know, in English, a noun is a person, a place, or a thing. Well, math has a very similar idea, and we call it a set. It's simply a way of grouping and naming things. The formal definition is actually beautiful in its simplicity. A set is just a collection of things. That's it. These things are called its members or its elements. Really, just think of it as a box with some stuff in it. For example, we could have the set of all integers, stretching off to infinity in both directions, or we could narrow it down to the set of just the positive integers, which we usually label with a capital N. We can even define a set based on a property, like set A here, which contains all the even numbers. And then there's the empty set. Now this one can feel a bit strange at first. It's a set with absolutely nothing in it, an empty box. But trust me, it's a surprisingly important idea. Okay, so now that we have our nouns, the next logical step is to see how they interact, right? How can we combine them and compare them to start building more interesting ideas? This is where Venn diagrams come in, and they're a fantastic tool. Why? Because they take these abstract rules and make them immediately visual and intuitive. You can actually see how the sets overlap and interact with each other. So let's just quickly break this table down. A is a subset of S if everything in A is also inside the bigger set S. Simple enough. The union of A and B is everything that's in A or B, or maybe in both. You kind of just scoop them all up together. And then the intersection is only the stuff that's in both A and B. That little overlapping section in the diagram we just saw. All right, we've got our nouns, sets. But a language with only nouns would be pretty boring. We need action. We need relationships. We need verbs. And in the language of math, our verbs are called functions. So what is a function? Well, it's just a rule. Think of it like a machine. You put an element from your starting set, A, into this machine. The function, our rule F, does something to it, and then it gives you back exactly one very specific element from the ending set, B. One in, one out. That's the core rule. This graph makes that rule totally tangible. For a function like f of x equals x squared, you can see that for any input value x you choose along the bottom axis, there is one and only one output value on that curve. That's the key to it being a function. No ambiguity. And here's some vocabulary that's absolutely essential. The set of all the things we're allowed to put into our function machine, that set A, that's called the domain. The set of all the actual outputs that we get back, that's called the range. So you can think of it this way. The domain is what you start with, and the range is how far you can go. Now, just like verbs in English can be very different, to walk is different from to fly, functions can describe all sorts of different kinds of relationships, and we can classify them to be even more precise. So here are two really important classifications. A function is one-to-one if every single output comes from a unique input. No two different inputs ever lead to the same output. On the other hand, a function is onto if it hits every single possible target in the output set. It doesn't miss any of them. It covers the whole thing. And this is where it gets really, really powerful. We can chain our verbs together to create more complex sentences. The output from one function, let's say G, can feed directly into another function, F. This is called composition, and it's how we build the incredibly complex mathematical machinery that runs our modern world. And hey, don't just take my word for it. As Elementary Classical Analysis puts it, Set theory is the starting point of much of mathematics and is in itself a vast and complicated subject. We're really just scratching the surface of the very foundation of a deep and powerful field. So, we've just learned the basic grammar of mathematics. We have our nouns to name things and our verbs to describe what they do. Now, with this new language in hand, what incredible stories about the universe are we equipped to write and to understand? The possibilities are pretty much endless.